On October 16, 2025, a joint press release from the Ukrainian Ministry of Defense and U.S. tech firm Auterion confirmed a major development in military technology. The announcement, verified through official channels, marked a pivotal moment, signaling a new direction for unmanned aerial vehicles, or UAVs. The statement revealed an AI-powered long-range strike drone named Artemis. More than just a concept, Artemis had already successfully completed a rigorous multi-stage testing phase and was officially approved for mass production. This wasn't a simple laboratory sign-off. The trials involved a comprehensive series of simulated operational missions designed to push the platform to its absolute limits. These tests validated its structural integrity, avionics stability, and performance under a wide range of environmental conditions, from severe crosswinds to extreme temperatures. Artemis is the result of a unique transatlantic partnership. It was developed by Ukrainian defense experts, bringing years of hard-won battlefield experience, in close collaboration with Auterion, a U.S. defense tech firm renowned for its open-source drone software and systems. This joint effort strategically combines Ukraine's practical, real-world insights into modern warfare with America's deep expertise in advanced software engineering and scalable systems architecture. The goal was clear from the outset: to create a powerful, adaptable, and cost-effective new weapon system for the modern era. In its primary role, Artemis serves as a long-range strike drone, specifically designed to penetrate contested airspace and hit targets deep behind enemy lines. Its basic specifications impress: a combat-proven range of about 1,000 miles and an 88-pound payload. The range was validated through multiple long-endurance flights over varied topography, carrying a payload equivalent to its maximum capacity to accurately simulate a real-world mission profile. A 1,000-mile reach fundamentally changes the strategic calculus, threatening critical assets located far from the immediate front lines. Meanwhile, its 88-pound payload is substantial enough to seriously damage hardened infrastructure, neutralize command and control posts, and disrupt logistical hubs. These capabilities, combined with its advanced software, firmly place Artemis among the most capable and versatile long-range drones available today. The timing of this announcement matters. The war in Ukraine has dramatically reshaped modern military doctrine. Drones have evolved from niche assets into tools that are absolutely essential for everything from battlefield reconnaissance to direct kinetic attacks. Out of sheer necessity, Ukraine rapidly became a global leader in drone innovation, pioneering new tactics and technologies under the most demanding conditions imaginable. Artemis represents the next evolutionary step, a system engineered from the ground up, built on the hard lessons learned from a peer-to-peer industrial war. Beyond the technology, the Artemis program signifies a renewed and deepened military cooperation between Kyiv and Washington. In early 2025, such a partnership looked unlikely, as crucial U.S. military aid was paused amid protracted political debates. Now the relationship has evolved. The U.S. isn't just providing aid, it's actively co-developing cutting-edge weapons systems with its Ukrainian allies. In this context, the drone itself becomes a powerful symbol of a strengthened alliance, a platform built for mass production, continuous improvement, and shared defense. But its hardware is only half the story. Stay with us as we dive into what truly sets Artemis apart: its sophisticated software brain and its game-changing, jam-resistant navigation system. While its impressive range and payload are notable, they aren't the full story of what sets Artemis apart. In a conflict defined by rapid innovation, raw performance metrics are only one piece of the puzzle. So, what is Artemis's true advantage? The game-changer isn't found in the airframe or the engine. It's in the drone's digital nervous system, its advanced, resilient software powered by the Skynode N mission computer. This military-grade computing core performs complex sensor fusion, but its real muscle is used for a standout feature: Auterion visual navigation. With this system, Artemis can navigate by sight. It constantly analyzes the terrain below, comparing visual cues with preloaded 3D maps to calculate its precise location. This capability directly counters one of modern drone warfare's biggest challenges: GPS jamming. Russia deploys powerful jammers to create protective electronic bubbles over key sites, broadcasting radio noise to overpower the weak satellite signals drones rely on. For a standard drone, this means drifting aimlessly off course. But Artemis is different. The moment its systems detect jamming, it performs a seamless handover. It stops listening for the lost satellite signal and starts looking at the world around it. The drone then confidently resumes its planned route and presses the attack, maintaining high accuracy even deep inside a GPS-denied zone. Against a drone like Artemis, traditional jamming becomes a minor inconvenience. The technology also solves a problem for Ukraine itself. Its own air defenses use GPS jamming to disrupt incoming Russian drones, which can complicate friendly offensive launches. Because Artemis can navigate without GPS from takeoff, it can operate from within Ukraine's own active jam zones. This gives commanders greater tactical flexibility and allows for more frequent, unpredictable strikes with pinpoint accuracy. Up next, how US-Ukraine collaboration turned lessons from the front into mass-produced capability. The development of Artemis shows how true partnerships accelerate military innovation. This wasn't a simple sale, it was a deep collaboration. Ukraine brought hard-won combat experience and clear performance requirements. The US, through Auterion, brought software, AI, and autonomy expertise. America excelled at big platforms but lagged on small, low-cost, attritable systems. Partnering with Ukraine let the US learn fast and adapt faster. Auterion confirmed a Ukrainian hardware partner, but kept the name confidential for security. Shielding facilities keeps production safe from strikes and disruption. Before deployment, Artemis faced rigorous testing to prove reliability and safety. Trials validated ground launches and GPS-assisted navigation. Crucially, it navigated to targets in GPS-denied scenarios using visual navigation. Range tests confirmed roughly 1,000 miles. Payload capacity was verified at 88 pounds. Terminal guidance demonstrated pinpoint final stage accuracy. With testing complete, Auterion announced the move to mass production. Scaling matters. In attrition warfare, quantity can rival quality. A fleet at scale can overwhelm defenses. Production lines are being established in Ukraine, the US, and Germany. Distributed manufacturing adds resilience and signals broader allied commitment. At first glance, the released image of Artemis shows a familiar delta wing shape, strongly reminiscent of designs like the Shahed 136. This isn't a coincidence. The delta wing configuration is a proven, stable platform, chosen for its inherent aerodynamic efficiency and structural simplicity. It provides a large internal volume for fuel and payload, while maintaining predictable flight characteristics, making it a reliable choice for long-range missions. But the similarities end there. Artemis integrates a prominent nose-mounted camera, the eye of its advanced visual navigation system, allowing it to operate independently of satellite signals. Additional antennas embedded in the airframe suggest more robust, redundant communication links designed to resist electronic warfare and maintain contact in contested airspace. A key differentiator is its electric motor. While uncommon for drones of this range, which typically use noisy two-stroke engines, this choice keeps the approach significantly quieter. The trade-off is often battery weight versus fuel density, but the tactical advantage is immense. Quieter flight drastically reduces the drone's acoustic signature, making it harder to detect by sound alone and severely compressing defenders' reaction time. Ultimately, it's what's inside that counts, the SkyNode N-Core, enabling jam-proof navigation and precise terminal guidance, ensuring the drone hits its mark even under heavy electronic attack. Beyond its individual capabilities, Artemis represents a monumental shift towards standardized, interoperable drones for NATO and its allies. This is about building a cohesive digital ecosystem, not just another piece of hardware. A common software layer, Auterion OS, enables seamless cross-nation interoperability and allows for continuous, fleet-wide updates pushed over the air. This means a German-built Artemis can use the same ground control station as a US-built one, and a pilot trained in one country can operate a drone from another. Target data from a Ukrainian reconnaissance drone can flow instantly to partners, who can then task their own assets using a shared, standardized data schema. This boosts collective effectiveness exponentially. The International Drone Coalition now counts 20 members and is growing, all committed to standardizing their unmanned systems faster, together. With Ukraine as a real-world innovation hub, this initiative helps battle-proof a common standard arsenal, rapidly iterating based on frontline feedback. For any adversary, the prospect of facing a tightly integrated, technologically advanced, and rapidly adapting alliance is a truly sobering one. Expect to see an entire arsenal of interoperable, battle-hardened drones emerge from this framework, creating an alliance that is far greater than the sum of its parts. Artemis is just the beginning of this new chapter. Subscribe for more deep dives into the systems and strategies that are redefining modern warfare.